Assalamualaikum guys. So today we are going to study another chapter, the electron configuration of ions. We have studied the electron configuration in 1.4 unit 1.4 part, right? We know the rule how to write, but still we don't know if any atom convert into the ion, how the electron configuration should be done. So this is what we are going to study here. I am Najmunisha Ashaf. I came to explain you about how to write the electron configuration of ion and atomic structure. Let's move on to the continue. So simply we are going to speak here how the electron configuration of ion happens. Okay, there are some set of the rules that is very important, right? You just go through one by one with an example, then you will understand how to write the electron configuration of ions. Yes, the first thing, whenever if you want to remove an electron, simply you can say forming a cation, right? So how the cation is forming? You have to remove the electron from your valence shell, right? Then the cation forms. There is a set of rules if you want to form a cation. So what is happening? When an electron are removed from an atom to form a cation, right? We know what is meant by cation. If an electron removed from an atom, then it will become a cation. That is what they say. They are always removed first from the occupied orbitals having highest principal quantum number. That is very important, guys. You should be able to understand this is very clearly. When you write any electron configuration, if you want to remove your electron, your first electron removing to form a cation, that should be the possibility should be where is the orbital having highest principal quantum number. That means higher value of the quantum number. So when you take lithium, okay, what is the atomic number? That is 3. So here, the formation of lithium plus, that means what? You're going to remove one electron. Shall we write the electron configuration of lithium? 1s2, 2s1. So what do you want to do? You have to remove one electron to form the lithium plus. You have to remove here. Why? As they said, if you want to remove an electron, right, first you have to remove under the highest principal quantum number. Here you can see 1 and 2. Therefore, the 2 is the highest one. So what you want to do is you have to remove from it. Right. Okay. So example is given here. When one electron is removed from your sodium atom forming a sodium ion, this is your electron configuration. 1s2, 2s2, 2p6, 3s1. Clearly it's visualized. What is that? Your highest principal quantum number, n is equals to 3. If you want to remove one electron, you have to remove from what? This, not 2p6 or 2s2. So this is what is happening. If you are going to prepare the Na plus, right? What is the configuration? The neon configuration, that should be 1s2, 2s2, 2p6. You have removed one electron, that's what is showing here. So earlier you had the 3s1, now we have removed. Because of what? It is having the highest principal quantum number. And secondly, if the principal quantum number is similar, What would you do? If there is a more than one occupied subshell for a given value of n, the n is similar, but more than two subshell, right? More than one subshell. That could be either T, P, S, right? So the electrons are first removed from the orbital with the highest value of L. So shall we order highest value here? Your S is the lowest, your P and the D. The highest value of L, 0, 1, 2. So which one remove first? Your D will remove first, then P, finally only S. This is the order, right? So what is happening? If you take an example, the boron atom loses the 2p electron before it loses the 2 electron. What is the electron configuration of the boron atom? Yes, the boron is 5, 1s2, 1s2, 2s2, 2p1. You can see there is no highest principal quantum number. Why? Who is the highest one? N is equals to 2. Right. Though it is 2, now you are having S and P. If you have the two subshells, two orbitals, what would you do? You have to go for the highest number of L value. So P is showing the highest value of the L value. Therefore, the P1 will remove the electron. So this is what you have to do. The 2P1 will remove the electron. So you will end up with what? 1s2, 2s2 electron. Right. So this is B plus. If you want to lose the B plus, become as B 3 plus. What is happening? Now the same one is applicable. You have 1s2, 2s2, the highest number of principal quantum number, right? So you can go 2 is here highest. So this will remove and you will get B3 plus 1s2 with 3 electrons. Did you all understand, guys? So please try to be understand. So when it is a boron, right, the boron is converted to boron plus by losing what? The electron from the p orbital. But the boron plus becoming as a boron 3 plus, how it's possible? Now you are having the same s orbital, L value, but the number of principal quantum number is differ. So highest principal quantum number will lose the electron, so therefore it lost from 2s2. This is the differ from this. Okay. So next, when two electrons are removed, right, from Fe. You know, this is your configuration of the Fe argon. You're having the 3d6, 4s2, right? The 4s2 electrons are losers ones that are removed even though in filling the 4s pills before the 3d. So did you understand what they are telling us? So when you are writing the filling order, before 3d, the 4s, yes, will fill that. So what will be happen if you want to remove the two electrons, right, together? The 4s2 electrons are removed one, then your 3d. You can see here why. The one thing is we have studied the highest principal quantum number and the filling order. The 4s2 is filling before the 3d also, it doesn't matter, but this is what is removing the electron. So you will end up with what? Fe2 plus argon 3d6. So you should be very careful about that when you are writing. These rows are very important to find the electron configuration of ion. Right. It's an additional electron. So all you want the Fe become as a Fe2 plus, so you have removed what the 4s2 directly and becoming as a 3d6. Now additionally another electron we have to remove from your Fe2 plus, so you should be clear whether it is Fe2 Fe3 plus. Right. If it is you can say that should be Fe2 plus 2 becoming as a Fe3 plus. Right. So that means what? It has to be lose one electron. So this is what you can lose from your 3d6 here. It will become 3d5. If not also. If you want to lose from Fe becoming as a Fe3 plus. What is the electron configuration? You have the 4s2 is there. Before that 3d6 is there. Yes. 3d6 is there. So what is happening here? Right. First 4s2 will remove the 2 electron. This 3d6 will remove 1 electron and becoming as a 3d5. This is also possible. This is what we are studying under the electron configuration of ion. Right, it's clearly showing you right what is happening here. The 3d6 becoming as a 3d5. As your 4s2 for orbital is empty, therefore you have to suppose to remove the electron from the 3d6. Electrons are added to an atom to form an anion. Until now we have studied what the cation. If you want to form an anion, what is the concept? You have to accept the electrons, right? So if it is want to accept the anion added to the empty or partially filled orbital having the highest value of n, which is the valence shell. So this is what seems to be similar like your cation one. So what you want to do, it will accept the highest principal quantum number as well as the highest energy level. So just go for this example. When you take the F minus, fluorine minus to becoming as a fluorine atom to become as a fluorine minus, right? You can use the annotation. Yes, when you want to make the fluorine atom becoming as a fluorine minus, right? What is the subshell? So what is the electron configuration of the fluorine? Yes, that is 9, 1s2, 2s2, 2p5. Here what is happening? The highest electron, highest quantum number. So here too you are having the both are 2, therefore you have to go for the subshell. So which one is having the highest L value, that will accept the electron. So now to becoming as a Fy minus, it will add the electron for the highest valency shell. So 1s2, 2s2, 2p6. This is what the electron configuration when an atom accepts an electron. That means it's forming an ion. So examples are given here, right? The electron accepting electrons, right? The fluorine accepting electron. So this is the configuration. The 2p5 is converting as a 2p6 according to the subshell. Right, we have studied how to write the electron configuration. So we have gone through the different type of the cation and the anion, how the major rules, right, seems to be similar. So one is removing electron, the other one is accepting electron. That is the major difference, right? If you understand the rule, you can do it clearly, right? Anyhow, guys, thank you very much. So we will see you with the next presentation. Until that, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh.